And so how does that affect the pricing and the economics? Can we talk a little bit about
Absolutely.
that?
So historically, string inverters were the most economical solution out there. And what you'd see in rooftop solar is you'd have these the string inverters, but when NEC code requirements, they required rapid shutdown in each of these sites.
Yep.
So then they had to come up with a rapid shutdown solution. APsystems has a AP Smart, that sister brand that also sells those. So there are solutions out there, but when you add that onto the cost of a string inverter, suddenly that cost is more expensive.
Right.
And also now with the QT2, we can be competitive with string inverters that have that added rapid shutdown cost.
Yeah. So the shutdown component.
Yeah.
What's that cost in a typical resi install? Is it like another $500 to $1,000? Or?
Yeah, it can take up as much as the data we've seen is, if you look at your string inverter cost, it can be at 50 to up to 70% of the string inverter cost added onto the system.
Wow.
So it's a tremendous cost increase. They thought they were saving money by going with string inverters, but then they add up all this rapid shutdown equipment, and then it's like, okay.
And microinverters don't need that.
Exactly. It's built into the design of it, so the code requirement is anything that's in excess of 80 volts.
Yep.
But because microinverters are under that 80 volt threshold, then that NEC code doesn't apply to microinverters. So they're inherently compliant. Even still, we still test our product to meet rapid shutdown requirements. We have certificate and everything, just to make sure that even if the AHJ doesn't necessarily know about that that 80 volt requirement, that we still have certifications.
Got it. And the 4.1 configuration keeps that voltage below that threshold as well. Mm-hmm. Got it. And let's also talk a little bit about the reliability angle on these. I understand there are some benefits to doing lots of microinverters on a commercial install than a string inverter.
Well, that's another thing we wanted to do with the design. Is when we got that initial feedback, it's like, look, I'm putting one microinverter on each panel compared to a string inverter connect to all these components. Well, as soon as rapid shutdown entered the equation, if you think about a 100 panel system, you've got 100 rapid shutdown devices or optimizers that are connected to each of these panels, plus your string inverter components. So now on a 100 panel system, it's exceeding 100 power conversion or power electronic devices. And so in looking at the 4-to-1, we have 25 microinverters on that same system. You're reducing your number of components out there by 75%. So that automatically increases the reliability, reduces the potential points of failure within that system. So there are some inherent benefits of that, just the architecture alone, in addition to the product itself being more durable and reliable. I'm sure you have listeners that'll be like, have rapid shutdown issues. They've heard about them. They've seen them. I saw a Solar Builder article on some pretty, terrible experiences with rapid shutdown devices. And, using a durable microinverter that has an IP67 enclosure, it's going to be, a little bit more rugged for that with the true Staubli MC4 connectors. So all of that increases your overall reliability on a site.